Today I am doing few theories first. 10 numericals we have done last class. Hello? 10. Okay. Now something related to electric field because remaining problems are based on this topic. Electric field. The simple meaning of field is space, or we can say area. So if we have a charge, some area around this charge is called electric field. So whenever you bring unit positive charge towards this existing charge, then space up to which there is some repulsive force due to existing charge acting is called as electric field. Like I had told, if suppose a dog wants to check its area is up to what. So dog, they have habit of barking. अगर एक कुत्ता भोंकते 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 दूसरे के गली में गया and other dog started barking upon him, then that dog came to know my area was restricted, I have jumped into some other area. So space surrounding charge within which when unit positive charge placed will experience force is called as electric field. The space surrounding charge within which unit positive charge placed experiences force. The space surrounding charge within which unit positive charge placed experience force is called as electric field. Just write definition, then we'll see one derivation. The space surrounding charge within which unit positive charge placed experiences force is called as electric field.
Yes.
Lines of force. If this is electric field of positive charge, I place here unit positive charge, then it will get repelled along the line joining two charges. Here also it will repel along the line joining two charges, repel along the line joining two charges. This imaginary line along which this charge will move when placed in electric field is called as line of force. So we say the path traced by unit positive charge. The path traced by unit positive charge when placed in an electric field. The path traced by unit positive charge when placed in an electric field is called as lines of force. Right. This definition also lines of force. The path traced by unit positive charge when placed in an electric field is called as lines of force. Written?
Yes.
Properties of lines of force. First, if this is positive charge and this is negative charge, line of force is path of positive charge. We all know current is nothing but flows in the path of positive charge from positive to negative. So same way as line of force is path of positive charge, it is assumed that line of force will start from positive and terminate in the negative charge. First property. Lines of force lines of force will start from positive charge and terminates in negative charge. Second. See, line of force are starting from positive charge. That means something coming out from spherical region radially outward will be perpendicular to the surface. Hello? Hello?
Yes, sir. Yes, sir.
That means we get one property like this. Lines of force are always perpendicular to the surface from where they start and terminate. Lines of force are always perpendicular to the surface from where they start and terminate. Right, two properties. Then lines of force are always perpendicular to the surface from where they start and terminate. Third one. Now, suppose I throw one body in air, then it will follow this projectile path. Correct? Hello? It follows parabolic path. How to get direction of the body at point P? By drawing tangent, 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 tangent. This you know for curve, I think.
Derivatives.
That means derivative. Okay, derivative is slope method. So if I want to find direction of a body moving on this curved path, then at that point we take tangent. See, if this is circular motion, a particle is at P. So how it is directed? Along the tangent outward. If it is at Q, along the tangent outward. At R, along the tangent outward. Correct now? Hello?
Yes.
If you are aware, to find the direction on the curve, it should be along the tangent. So if this is positive charge, this is negative charge, line of force will start from positive, go towards negative. So at this point, if I want to find the direction of that positive imaginary charge, then I should draw tangent here, tangent here, tangent here. This tangents at any point represents direction of electric field at that point. So tangent drawn at any point represents direction of electric field at that point. Fourth is very important point again. Can we have direction of field in two way, either this way or this way? It has to be only one, either outward or downward. Hello?
No, sir.
If line of force they intersect, then at common point we can have two tangent, which is practically not possible. You can't have charge at this point either moving this way or this way. It will follow only one direction like this. Huh? Hello? Hello? So can we
Yes.
say that line of force never intersect? So this is all imagination and then we have to prove it. If they are intersecting, what will happen? We will have two direction of field at the same point. Hello?
Yes. Yes.
Is it possible that at
No,
same
sir.
point charge is traveling in two directions? Charge follows only one direction.
That's not possible.
Pardon?
Hello.
Yeah.
Hello.
Yes, yes, say.
It's not possible, right?
It's not possible. That's what I'm saying. So we can say lines of force will never intersect. Never intersects. If they intersect, then at same point we have two directions of field, which is not possible. So write this third and fourth. Tangent at any point represents direction of electric field at that point, and line of force will never intersect, because if they intersect, then at same point we can have two direction of field, which is not possible.
Yes, sir.
Now suppose this is one charge and this is another charge. If we get this way the field, now can you predict which charge is more magnitude? Here the fields are wide, say, and here it is making small angle. Wherever it is making small angle, that means it is at that point it is crowded. Suppose this is one positive charge, this is one again positive charge. This way I draw the field direction. Where is the field strong? At this point or at this point? At A or B, where the field is strong?
I think he.
At A. So wherever it is crowded, there its strength is more. And we also know if something is focused at one point, then all will give more strength. But if it is diverging from one point, then it will give lesser strength here. United we stand, divided we fall, we know. So we have one property. Lines of forces are crowded at the place where intensity is maximum. Lines of force are crowded at the place where intensity is maximum. Right, fifth point. So by chance it is given like this, Q1 and Q2 in the exam. And they show like this. Can you tell me which is positive and which is negative? Q1 is positive, Q2 is negative, correct. But if they show like this, Q1, Q2. Now, who is positive, who is negative? Again, Q1 is positive, Q2 is negative. But whose magnitude is more? Check this angle between these three. Angle same magnitude. Angle smaller, then larger magnitude. Okay? Hello?
Yes.
Write down fifth point.
Yes.
I will send one sheet which is based on electric field and intensity. Daily 10 MCQs you are trying. Today I will send. Then I am giving you planner of the week. Lines of force are crowded at the place where intensity is maximum. 6. They can pass through insulators, but not through conductors. They can pass through insulators, but not through conductors. So because conductors, they have free electron, which are in random motion in so many directions. So net field will become zero. That's why they cannot travel through this, but they can pass through insulator. Can I clear this?
Yes, sir.
Planner I'm giving, that you will write, then I'm starting. Today is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Test on MCQ. From Today you will do only 5 MCQ. Tomorrow 6 to 20. Here again 21 to 25. Here 25 to 30. No, 25 to 40. Then 40 to 41 to 45. 46 to 15, 46 to 15, 1 to 60 test only on that. And then whatever taught, write and practice 2 times. Same thing here, same thing here. So Sunday test will be on theories which I am going to do on Monday, Wednesday, Friday. And this 60 MCQs में से any 25 available. Here theory. Today I did what is electric field, lines of force, properties of lines of force. Then I'll be doing what is electric field intensity due to point charge. Then electric dipole. Then intensity at axis. Then equator. Then any point. Then 8th one torque. So out of 8 theory, I will ask you any 4. This is your work for Sunday's test. Please write down so that you remember what you have to practice.
So we'll observe derivation.
Let's see, today I will complete 3 derivation. All are simple derivation. This much you have to work, see, to get good marks. This very least and bare minimum I have given. Only 5 I have given MCQ. And today's theory, even if you read, you will understand this 3 part which I did just now. How much time it will take for you to revise this 3? I don't think more than 10 minutes. Space surrounding charge is called electric field. Path traced by even the line or path traced by unit positive charge is called line of force, and 6 pointing property. Hardly 10 minutes it will take. This is not Monday I will teach, Wednesday I will teach, Friday I will teach. In that, this much I will do. So out of 8, any 4 theory. And out of 60, any 25 MCQs. Written full?
Yes.
Define electric field intensity. Define electric field intensity. See, intensity means strength or energy. So if suppose there are 2 friends, एक दूसरे को ऐसे ही बोल रहे हैं, दिखाओ क्या, ये दिखाओ क्या, मतलब कि इसमें भी ताकत नहीं है. दूसरा आके एक को बजा दिया जोर का, तो उसके पास ताकत था ना, इसने दूसरे को हिट किया, फोर्स दिया. So if this charge wants to check इसके पास कितना ताकत है, तो सामने वाले को मारेगा ना. अगर इस सामने वाले ने इसका हाथ पकड़ लिया, मतलब मुकाबला टक्कर का होने वाला है. हाथ पकड़ के इसको बजा भी दिया, तो इसका फोर्स ज्यादा है ना. Hello?
Yes.
See, E1 wants to check its intensity. Then it will apply force to Q2. If Q2 wants to check intensity, it will apply force to Q1. So indirectly it is force acting on unit charge. But for Q1, that force should act on Q2. And for Q2, force should act on Q1. This is called electric field intensity. Force acting per unit charge is called as electric field intensity. Force acting per unit charge is called as electric field intensity. It is given by E equal to F upon Q. So its SI unit is Newton per Coulomb. Its dimension is M1 L1 T. Say Newton is M1 L1 T minus 2 and Coulomb is A1 T1. So A1 L1 T minus 3 A minus 1. It is a vector quantity directed outwards for positive charge and inwards for negative charge. Right. Now, what is outward, what is inward? I am explaining with example. Just write down this definition.
Yes.
Now, what is meaning of outward for positive, inward for negative? This is suppose positive charge, and at point P we want intensity का direction. Positive charge outward. If it is negative charge, then it will pull you inward. This is the meaning of outward. Derive expression for electric field intensity due to point charge. Derive expression for electric field intensity due to point charge. Suppose Q is point charge at A and capital Q is charge at B, separated by distance R. So force acting on this Q is suppose F, which will be repulsive in nature. So by Coulomb's law, force of repulsion on Q, F equal to 1 upon 4 pi epsilon Q by R square. Electric field intensity, comma E is force acting on Q because I want intensity of this charge. So it will be 1 upon 4 pi epsilon naught Qp by R square divided by Q. Q cancel. E is 1 upon 4 pi epsilon Q by R square. So intensity due to point charge at distance R is 1 upon 4 pi epsilon Q by R square. See again from start. Consider 2 point charges Q, capital Q to be situated at points A, B in air at distance small r apart. Therefore, by Coulomb's law, force of repulsion on capital Q is 1 by 4 pi Qp by R square, electric field F by Q. This is expression for intensity due to point charge. Any doubt? Hello, any doubt?
No, sir.
Done? Electric dipole. So di means 2 and pole means at ends. So actually 2 equal and opposite charges separated by finite distance is called as electric dipole. So if we have two equal and opposite charges plus Q minus Q separated by finite distance, let us take 2L, then it is called as electric dipole. It is as shown. Write this much and diagram. Once you have followed all, hello?
Yes, sir.
Followed everything?
Yes.
Paper you have sent, status paper? Once you have
Sir, I
sent,
have been bedridden for a day.
I can't.
I've been bedridden for a day.
I can't hear you properly.
So I've been bedridden for a day.
What you are saying, you have not done. Once you have submitted the paper. Hello. Hello, once. Hello.
Saying, I'm just saying that he was bedridden for a day because he got hurt while playing.
टाइप करता टाइप करके बताओ जरा मुझे चैट पे.
Yes.
Hello.
Hello. Yes, sir.
So you have submitted the paper.
Sounds is on mute.
So it seems says something. Sure, what do you do? Okay. Electric dipole moment. The product of any one charge forming electric dipole and finite distance between them is called as electric dipole moment. It is given by P equals to Q into Q. It is a vector quantity directed from upper this electric dipole you have written no definition. So it is a vector quantity directed from negative charge to positive charge. is a vector quantity directed from negative charge to positive charge. Its SI unit is coulomb meter. Copy. Can I clear this one?
Yes.
Derive expression for electric field at any point on axis of electric dipole. Derive expression for electric field at any point on axis of electric dipole. See, first of all, dipole means two equal opposite charges. I know formula for point charge at distance r. What is E? 1 upon 4 pi epsilon q by r square. Outward for positive, inward for negative. So suppose this is negative charge, this is positive charge, separated by distance 2l. If O is center, then this OA distance, OB distance will be LL. C is a point at a distance R from center O. Now for this positive charge, field will be outward, I am calling E1. For negative charge, it will be inward, I am calling it as E2. Whenever two vectors are in opposite direction, what is result? Add or subtract?
Subtract.
Subtract. If they are in same direction, then add. If they are inclined by any angle,
Then
parallelogram. We take parallelogram. No?
Yeah, cos theta also.
Yes. That means it is root of E1 square plus E2 square plus 2E1 into cos theta. So consider an electric dipole consisting of two equal and opposite charges minus q comma plus q at distance 2L. Let O be center of dipole. Therefore, OA will be OB will be L. Let C be a point at distance small r from center O. The electric field at C due to positive charge Q at A, comma E1 is 1 upon 4 pi epsilon Q upon distance between A and C square. What is distance between A and C? Can you tell? What will be direct? Huh?
Could you repeat, please?
And what is distance between AC? From this figure, can you tell? In R and L?
A 2L minus R.
No, see, I have divided into two parts. O to A is L and O to C is R. What is AC?
R minus L.
Correct. It is R minus L. See, this is O, this is A, this much is L. From here to here it is R. So this distance will be what? R minus L. And because charge is positive, it is directed outward. Okay? First equation clear?
Yes.
Copy this much. Draw the diagram and copy till even forward. Can you suggest what will be distance between B and C? R plus L. The electric field intensity intensity due to negative charge minus Q at B, comma E2 equals to 1 upon 4 pi epsilon minus Q upon BC square. V2 equals to, we don't write actually minus, only magnitude will write Q upon R plus L square. It is directed inwards. The resultant intensity at C, comma E equals to E1 minus E2, because denominator of E1 is smaller, therefore its answer is larger. So we get E equals to 1 upon 4 pi epsilon naught Q upon R minus L square minus of 1 upon 4 pi epsilon naught R plus L square. 1 upon 4 pi epsilon naught Q 1 upon R minus L square R plus L square equals to 1 upon 4 pi epsilon naught Q R plus L the whole square minus of R minus L the whole square. The denominator will become R minus L square R plus L square by cross multiply. So 1 upon 4 pi epsilon naught Q R square plus 2LR plus L square minus R square minus and minus will become plus, and here it is minus L square upon A minus B, A plus B is like A square minus B square and power form. R square, L square, L square cancel. E equals to 1 upon 4 pi epsilon Q 4LR upon R square minus L square. Please copy to this.
Yes.
I can clear now till last line. Since L is very small than R, L square can be neglected in comparison with R square. Therefore, E is 1 upon 4 pi epsilon Q into 4 LR upon r square. L square can be neglected. This will be square. E equals to 1 upon 4 pi epsilon q into 2l into 2 into r upon r raised to 4. That will become r raised to 3. But q into 12 is p, which is called as electric dipole moment. Therefore, E equals to 1 upon 4 pi epsilon 2p upon r cube. Right. This is an expression for electric field at any point on axis. Therefore, E bar will be 1 upon 4 pi epsilon 2 p bar upon r cube. That means they are in same direction. Is completed. 1 upon 4 pi epsilon 2p upon r cube is electric field at any point on axis.
Yes.
The angle between axis and p bar is 0. Right? Expression for electric field at any point on equator of electric dipole. Equator is line passing through center and perpendicular to the axis. First see diagram, then we'll start. Electric dipole consisting of negative and positive charge separated by distance 12. O be the center, OA equals to O, B equal to L. Let C be a point at a distance R from center O on the equator. Draw AC and BC. What will be distance AC? Is it root of R square plus L square? BC is also R square plus L square. So ABC is which type of triangle?
Right angle.
Isosceles. ABC, I said. ABC, not OAC. Isosceles. So these two will be base angle. Can I take same theta theta? Hello? Then we take same to theta theta. Draw this diagram then. AB is 2 point where positive negative charge are placed. So electric dipole consisting of positive and negative charge. Separated by distance 2L, O is center, OA equal to OB equal to L. Should I have solved that sums 1 to 10 which I had solved in the class properly? Or Veer, any of you have solved it properly?
So could you repeat?
I said the 1 to 10 sum which I did in the last class. Have you solved it properly? Or on the
Yes,
notebook
sir,
properly? Just can you take
Yes,
photograph
sir.
and send me? One student wants that.
So I've skipped a little steps too because I wrote it fast.
So if anybody is written properly, now just send it so that I will make PDF and send to that one.
1 second. So when do we have to send it?
Today, tomorrow, anytime you send.
Okay.
Wednesday I have got class, his class, so I will give in that solved sums. If it is possible, sir. Completed diagram. Now intensity at point C due to positive charge will be directed outward or inward or in any direction. It will be outward along the line joining that point and charge. Okay. Hello. Direction
Yes,
of
sir.
intensity due to positive charge will be directed outward. For charge at B, what will be the direction of intensity?
I'll be towards.
Inward. E1, E2. E1 is outward, E2 is inward. Just draw this two diagram again, showing the direction properly.
Sure.
Yes, yes.
Sure, all my sums are complete from 1 to
Whatever I have explained, 1 to 10 I told or 1 to 12 I have explained.
no, we've done 1 to 14.
अच्छा हाँ चलेगा.
But sir, one question is incomplete, like the
ठीक
fifth.
है ठीक है. That you don't write. I will write that. Just leave the space there.
Okay, okay. So I'll send it to you by tomorrow.
No, no problem.
Pardon.
Done. This two diagram done. E1 outward, E2 inward. Then draw one ray parallel to AB. Can you tell me what is this angle? Theta.
Okay.
Because these two lines are parallel. This is transversal. These are called corresponding angle theta. Similarly, these two lines are parallel. This is transversal. What are these two lines called? These two angles called, sorry. Alternate. So even this will be theta. So I have got two vector E1, E2, angle between them is 2 theta. So can I get resultant by parallelogram law? What is formula? Root of E1 square plus E2 square plus 2E1 E2 cos of 2 theta. Correct?
Yes.
See, one way I could have resolved. Then two vector will get cancelled and 2 will add. Or I can say E1, E2 are two vectors, angle between them 2 theta, then resultants can be found by parallelogram. Just complete the diagram. Then I am showing you how to get result. This is the resultant. Consider an electric dipole consisting of two equal and opposite charges plus q comma minus q at points A comma B separated by distance 2L. Let O be the center of dipole. Therefore, OS equals to ON equals to L. Let C be a point at distance R from center O. Draw CA comma CB. Therefore, CA equals to CB equals to root of R square plus L square. Let angle CAB equals to CBA equal to theta. Now, electric field at C due to positive charge Q at A comma E1 is 1 upon 4 pi epsilon Q upon AC square. E1 equals to 1 upon 4 pi epsilon Q upon AC square will become R square plus L square. It is directed outwards. Electric field at C due to negative charge at B comma E2 equals to 1 upon 4 pi epsilon Q upon CB square. So E2 equals to 1 upon 4 pi epsilon Q upon r square plus L square, it is directed inwards. You can clearly see magnitude wise they are same. Just copy this one.
Yes, sir.
Thus, resultant intensity at C, comma ER equals to E1 square plus E2 square plus 2 E1 E2 cos 2 theta. Since E1 is same as E2, so resultant will be E1 square plus E2 square plus E1 square plus 2 E1 E1 into cos 2 theta. ER is 2 E1 square plus 2 E1 square cos 2 theta into ER equals to 2 E1 square plus 1 cos 2 theta into ER equals to 2 E1 square cos 2 theta is 2 cos square theta. Therefore, ER equals to 2 and 2 plus square root is 2 into E1 into cos theta. So resultant is 2 times 1 upon 4 pi epsilon cube r square plus L square. Cos theta is adjacent side L upon hypotenuse root of r square plus L square. So resultant will be 1 upon 4 pi epsilon naught 2 QL upon. This whole bracket power is 1 and this will be half. So it is r square plus L square raised to 3 by 2. But 2QL equals to P equals to electric dipole moment. So resultant is 1 upon 4 pi epsilon P upon r square plus L square raised to 3 by 2. Again copy till this, then we will say why we can neglect that L square. Copy. What is direction of resultant and P bar in our diagram? P is from minus Q to plus Q. And this E bar was directed ulta, na? Hello?
Yes.
So what is the angle between E bar and this P bar? 180.
Yes.
So in vector form, P ka ulta is ER. So we write negative. So angle between intensity and P bar is 180. Here intensity at any point on equator and P bar is 180. Now complete the last line completed. Yes, that's all for today. Please revise and keep this much. Next lecture will be intensity at any point on dipole. We did equator, we did axis, then we'll do any point. Then will come torque. That will complete your first chapter ka theory. And then I will do numerical. So this week, this first chapter of electric field and charges I will complete for. So that's all for today. Let's meet on Wednesday. Keep revising as per the planner. I will send the